So what I was explaining was if Q becomes 0, what will happen to the force? Okay, so Q is 0, F is 0. So you see in the slide I have put one more small figure down. So you can see that electromagnetic wave is falling on the charge Q. So I have shown electric and magnetic vector of the wave, and the wave is approaching charge Q. So the force acting, it is shown by an arrow mark and it is shown as F. Okay, so if in presence of Q, if I put a non-charged particle, that is Q is equal to 0, then you can see that what happens, F value will become 0. So what is the meaning of this? So electromagnetic waves, that is light, so you know the whole band, that is X-ray, gamma rays, etc., all will come as electromagnetic radiation. So electromagnetic radiation, they will have effect only on the charged particle. Uncharged particles are not affected. For example, photon, neutron, mu zero particle, phi zero particle, sigma zero particle. These are all uncharged particles. These are okay. So only the charged particle will interact with the electromagnetic field. That is the significance of that. That I have shared in the second slide. So now you go to the third slide. So I have written there Minkowski space. So actually in the PowerPoint I have introduced a full discussion on the Minkowski space. I will share it with you people. So it will be very clear what is the Minkowski space. So to explain Minkowski space, what we have to remember is the earlier studies of vector algebra or vector calculus, okay, or vector coordinate system. So usually vector means we'll be thinking of a two-dimensional vector, a three-dimensional vector, etc. But Minkowski space, it talks about a four-dimensional space, and those four dimensions are decided by four vectors. So to understand Minkowski space, first we will study, or we will try to remember what we have learned about three-dimensional vector space. So for that we'll consider the Cartesian coordinate system. So there are three vectors, one along x-axis, that x itself is a vector, it shows direction, and y is another direction, z is the another direction. So if you want to show the direction and magnitude separately, so then you can associate unit vectors I, j, k along the x, y, z axis. Then x, y, z will simply give you the value of the magnitude, and directions are given by the unit vector. So let us assume there is a point A in this space. So I want to locate the point in space using the vectors. So how you will write vector A, that is A with an arrow mark on its head. So A equals to Ix plus Jy plus Kz. That is, it is a three-dimensional vector. We will be showing it by, that is the fundamental way of showing it. Suppose if I introduce a fourth vector into that, then the whole system will become a four-dimensional space. So that is the Minkowski space. So fourth vector, let us say I will take some value. Let us say I will take m. M is the vector, and let us say small n represents unit vector along the axis showing the new vector m. So now how to show the point A in four-dimensional vector space? So you have to show it as Ix plus Jy plus Kz. So now the new vector is m, and along with that identity vector is n cap. So you will add the fourth component n cap m. So totally this will show you a four-dimensional vector in the four-dimensional space. So this was identified or devised for first time by the person Minkowski. So this is called a 4D space, or it is also called Minkowski space. So 4D space, what you are using? You are using four vectors to show the four directions. So that is why the vectors which are you are representing in Minkowski space, they are called as four vectors. Okay. So as the name itself indicates, there are four vectors in the representation. So earlier we used three, now it is four. So it is called 4D space or Minkowski space, or also it is called as vector space in four dimensions, or a Minkowski space, okay, or it is the vector, it is called as a four vector. with that, now you come to a slide. I have given you, there is a cone. You can see the cone is there. So along vertical axis I have taken t, and horizontal axis I have taken it as x. Okay. So this is actually only I am using x direction for the Cartesian changes, and y direction actually it is ct, c into t, y axis. But so vertical axis is c into t, horizontal axis is x. So c value is taken as 1. So for y it is taken as 1. While deriving another vector, it is called vector s. I will explain that. For the time being only you remember c equals to 1. So what is y axis? It is only t. Fine. So now you can see a cone has been formed by two arrows, and you can see there is a horizontal plane below, and I have identified 2 points in the cone. So I called one as event 1, another as event 2. So what is significance of this cone? So what is significance of this cone? So this cone is also called as light cone. So why it is called light cone, or it is also called Minkowski cone, it is also called. Okay. So you can see two lines which are forming the edges of a cone. They are shown by an arrow mark. You can see the diagram. So what it shows? It shows the direction of light. So light can go, it can go along x-axis as a function of time. So how its trajectory of a photon associated with the light changes, that is shown as the boundary line of the cone. Okay. So what is that line then? If there is a particle moving with velocity of light, then it will fall on the arrow mark which forms the edge of the cone on the right side. So right side, you know, x value is positive, and anyhow t is up, so it is positive only. So x is positive, t is positive. That means as the photon moves, so it follows the trajectory shown by the arrow mark. That is meaning of that. And you can see I have made a mark there. I have written 1 unit in the diagram. So what is 1 unit? So 1 unit is taken equals to 3 into 10 to the power 8 meters. Why I have taken it as 3 into 10 to the power 8 meters? Because the edge of the cone, it is for the photon. So what is velocity of photon? That is velocity of light. That is c, isn't it? So c means it is how much photon travels, 3 into 10 to the power 8 meters per second. So if I take 1 unit of